All right. Let me pull up the slides here. Okay, so we're doing areas between curves and stuff like that. You know what? Actually, let me start off with maybe a little, just a quick little review. So for those of you, again, who maybe are a little bit behind, you won't be too far behind. So if we know already that areas are signed, right? So we have signed areas. And that's our usual integral, right? That's the signed area. Right, and so if I plot this like this, everything above the x-axis, these are all, that's positive area. And this is all negative area. Right, and they can generally, cancel each other out and stuff. If I ask you, though, I could ask you for the absolute area. And that means that what you're going to do is I want you to actually find the total area. So I want, or maybe unsigned. Maybe let me put that in here. So unsigned area. And so now I'm saying I want everything to be positive. Right? And part of the reason why we call it the absolute area is that one of the ways that you could do, area under the curve. One of the things that I want you to do is usually we'll say like, oh, take the absolute value and integrate that. So if you integrate the absolute value, that will give you the entire area under the curve and not just the signed area, right? And then you can talk about the area between two curves. See, I'm so thankful last year that my birthday didn't land on the day that I was lecturing. All right. So, but I do appreciate the wishes, everyone. Okay, so if we have two curves, y equals f of x and y equals g of x, and we want the area, and we want the area between them, then what we're going to do is we're going to integrate the difference of these two functions, right? So we integrate a to b f of x minus g of x dx, like that. Okay. Okay, so these are basically how we're going to do things. And there's a couple of other little things like, okay, sometimes you want to find the area, but it's actually easier to integrate in the y direction instead. You kind of have to like turn your head to the side and view the integral that way. And then we can mix these things. So you could, you can have two curves that cross over one another and you have to find the areas between them like that. So there's a couple of different variations of these themes, but this is kind of like the main idea of all of them. Maybe let me title this one. So this one here is the area between curves. Between curves. Okay, so that's what we're going to focus on for today's lecture. Yes, I'm sure. Yes, canceling all the work, I'm sure only benefits me. Yeah, I wouldn't get into trouble at all. All right. So let's start off with a poll. Let's do this. Okay, so there's no computation to be done here. Everyone. So take a look at this, see if you can do it. Again, there's no computation. You just kind of have to eyeball it and see if you can interpret what it is. And I think actually last year we did give something like this as a term test question. I think, I'm trying to remember. But basically we gave you some big, ugly area that was bounded by like a bunch of functions, and you had to set up the integral that actually gave you the area that you wanted. So you didn't have to like evaluate the integral at all. All you had to do was write the integral down. But because that's really our goal in this section is, can you write down the integral? Because after that, if you can write down the integral, especially since we're remote, you can just go plug it into an integral calculator and you get the answer, right? So for f of x minus g of x, do we simplify the subtraction then use FTC? It's totally up to you, Olis. That's a great question. So like, if you want to split them into two different integrals, you absolutely can. Or you can integrate them together. It's your call. You can do whatever you want. Sometimes one is easier than the other, but generally they're the same difficulty. So I don't think you should have to worry about that at all. I usually keep them together. The only time for me to separate them is if, one obviously has some symmetry that I might be able to take advantage of. That's the sort of time that I might separate them. Otherwise, I tend to leave them together. McQueen's questions? Jude, I don't know what McQueen's questions are. I am very confused.
That makes two of us, Tyler.
Yeah, I don't know what that is. Yeah, I mean, that my interpretation of what you were asking for is if you would write the integral of f minus g was the integral of f minus the integral of g. And what I was saying here is you could do it either way, right? Okay. Multiple choice, no, Jude. There won't be any multiple choice. So the final exam is going to look exactly like the term test, only twice as long and twice as many questions. In the video, I simplify. I mean, you should do any simplification that makes your life easier. If it doesn't make your life easier, don't do it, right? 6 questions, 2 hours, Jude. Yeah, that sounds about right. There might be, I mean, there might, it is a 3 hours,
isn't it?
Yeah, it's a 3 hour exam. And so I think we're going to aim for 6 questions. There could be more or less depending on like if one question is a little bit heavier, we might do less questions. If some of the questions are a little bit easier, we might do some more. But the idea is for it to be the same, right? When we multiply the integral by 2, is it something related to even and odd functions? So Chifeng, yes, there's this thing you can do with, if you know you have an even function on a symmetric interval, you can, right, and you want to find the area, then you can just find the area from 0 to 5 or whatever your number is and multiply that by 2. That'll give you the area from -5 to 5. So we actually have a question like that coming up, and I'll point it out when we get to it. And so you'll kind of see that at work when I actually do it. Yeah. Yeah, so everyone, the exam will look very, very similar to what you've done so far, right? It's just, it'll be longer and more questions. But otherwise we'll look exactly the same. The instructions will be the same. The way that you upload it to CrowdMark will be the same. Everything will be the same. Yeah, it's a 3 hour exam. Y classes are typically 3 hour exams. And then like H classes are 2 hours. That to me is weird. For me, it was always 3 hours. Everything was 3 hours, but we get a list of topics to study soon. I don't know when we can make that, simply because, I mean, we haven't made the exam yet, right? And until we get together as an instructor team and decide what exactly we want to do, I don't think that there's a lot of advantage in us giving you anything, because either we're committing too early, right? Or, and perhaps unnecessarily restricting ourselves, or by virtue of not doing that, we have to give you too many topics, which kind of eliminates the benefit of doing that in the first place, right? So, but you will know relatively soon, right? Definitely, I think before the exam period starts, like before the last day of classes. Yeah, we'll see. I don't think it's going to be terrible. It's going to be what to study, what not to study. Yeah, I think right now, tentatively, we're looking at, by the way, we're at 80%, so we'll close it in about 30 seconds here. We're looking at, you know, we don't know exactly what it'll look like, but I think it'll be like, these are the subjects we're really going to look at, and these ones not so much, right? If at all. Yeah, that is a good point. Okay, so let's take a look at what we got here. We're pretty unanimous on this, which is pretty good. So we said B, which is a great start, and B is absolutely the correct answer. So like I said, we're kind of looking at the area between two curves, right? And so we're going to take G of X and we're going to take H of X. We're going to subtract them and we're going to evaluate that integral, right? So yeah, exactly it. And I mean, there are a couple of points here worth making too. So let me maybe...
Your screen didn't switch.
No, I know. I'm still switching it over. I got to hit a bunch of buttons and stuff. Okay. All right. So we had something, I guess I should have copied the image over, but our image looks basically like, you know, I can BS it. There we go. That's what our image looks like, right? And we were told that this is y equals g of x, and that this is y equals h of x. All right. Here's C, and here is D like that. Okay. Okay, interesting. So Jude, actually, yeah, we could definitely do the absolute value. That's actually a kind of a great point if you want to. So we end up getting that our answer here, we really want to subtract the bigger function from the smaller function in order to get the correct area. So I'm going to do CD of g of x minus h of x. Now you say, what about the absolute value? So you're absolutely correct. We could use the absolute value here. But note that the g is always bigger than h, right? And since g is always bigger than h, that means the absolute value of g minus h is already positive, right? So g minus h is already positive. So the absolute value of g minus h is just g minus h, right? So the absolute value doesn't add anything there. Where that absolute value is really going to come into play, is if you had something that looked like this. Maybe that's one curve and this is the other curve. Okay, if you have a curve like that, then in that case, you definitely want to do the absolute value, right? Because it's going to already account for you the fact that they're switching, and the absolute value will make sure that the answer you always get out is positive. But like I said, because we had put g minus h to begin with, we're already going to get a positive answer, so the absolute value doesn't add anything. Now, an interesting kind of point here is if we had screwed this up and we'd accidentally done h minus g instead of g minus h, we still would have gotten the right answer, but we would have gotten a minus sign instead. And in that case, all you say is, oh, shoot, look, I made a mistake. I accidentally put them in the backwards order. I got negative 14, so my answer should be positive 14. And if you do that on a test, that's totally fine. Don't erase everything and redo it. Just write to us, I screwed up. I should have switched these. And so the correct answer, is to switch the sign and get positive 14 or something like that, right? And I think it's worth kind of pointing out that a lot of people kind of freak out that, look, here h of x is pretty much always beneath the y-axis. Could we switch C and D to fix that? Yes. Yeah, you could, Abdul Rahman. It's kind of it's an unorthodox solution. Like we don't typically use it, but mathematically it does work out. Yeah, you could do that, and mathematically it would work out. But it is also totally fine just to say, look, I got it backwards, and I'm going to flip the sign just to make it the correct answer, right? Yeah, no problem. So a lot of people, though, and I want to point this out so that it doesn't bother anyone later, if you look at this thing, all this area is beneath the x-axis, right? And yet what we're saying is that when we want the area between these two curves, I want to make sure that the area is positive. But notice that I have actually accounted for that in the negative h of x, right? When I subtract two curves from each other, it actually doesn't matter what of them lie beneath the x-axis, what of them lie above the x-axis. The only thing matters is the relative difference. And if you're computing that relative difference, like I said, you don't have to worry about what falls beneath the x-axis. You can just subtract them and integrate, and everything works out fine. Okay, so don't worry about the fact that in this case, some of it lies beneath the x-axis. It won't make a difference in terms of your integral. Okay, and if you have any confusion about that, I'm happy to kind of go into it a little bit more detail. There's more we can say about that. But if it's not bugging you, then we don't need to worry about it. But it might also just be that we need to do a computational example, and I can show you that firsthand. Okay, so here maybe is a computational example, though this one isn't the difference between two curves. Here, so I got this comment, because it's negative h of x, does that make it g of x plus h of x? You don't want to write that. What it's saying to you is, let me do an example once we finish this one, and I'll show everyone why the only thing that matters is g minus h, right? I'll go into that in a little bit more detail. But let's do this one first. And I want to say, you actually can plug this into Wolfram Alpha, okay? And Wolfram Alpha will actually answer this for you, right? You can say, find the total area under the graph of the function blah, and Wolfram Alpha will just pump out the correct answer. But obviously, let's practice this without using a computer and see if we can, correctly break our intervals up in order to be able to compute, the total area. But know that once you get to the integrals, like once you've set up the integral, then just plug it into a computer, right? We're not worried about it. It takes a little bit to integrate these things. Once you get the integrals, just plug them in and see that you get the right answer. Do you need to graph it? You don't. I think it helps though, because then you'll know, yeah, exactly. You can do the table to figure out where it's negative and where it's positive. And you can imagine that if we weren't in a remote environment where you had easy access to a computer to graph it, then you would have to use the table, right? But in this sort of environment where you could just plug this function in and see where it's negative and where it's positive, that's great. You can totally do that. But yeah, you would have to use a table if we were in person. Yeah. What did I get for this anyway? Let me just... Right, okay. Right, note as well, it's relatively easy for, I think, you all to make these sorts of questions, right? You can just be like, I'm just gonna write down a function, see, try and do its integral yourself and compute its area under the graph, and then ask Wolfram Alpha for the answer, right? So if you want extra practice questions, of course you can come to us, but alternatively you could, just kind of plug it into a computer and try and do it yourself. So if you just do the integral from, well, you probably mean 1 to 3, yeah. So, okay, yeah, Hasan, that's a phenomenal question. If you do the integral from 1 to 3, you won't get the correct value. Well, I know the answer. The answer is no. Actually, if you just do the integral from 1 to 3, you will definitely get the wrong answer. It's not to say that that's a guarantee if I gave you a different function, for example. So let's say if this function were everywhere positive and you integrated it from 1 to 3, you would get the right answer. The problem here is that the function is actually negative somewhere, right? Exactly. And so those parts, if you just do the integral, the negative parts are going to cancel the positive parts, right? And so you're actually going to get a smaller answer than the correct answer. Do we have to break the interval on this one? Yes. I mean, basically, you're always going to have to break the interval if there's any switching, right? Like if it always stays above the x-axis or below the x-axis, you won't have to. But if there's any switching between positive and negative, you are going to have to break the interval up, right? And that's what the absolute value does, right? The absolute value says break this integral up into the places where it's positive and negative, compute the positive areas that are already positive, don't do anything, compute the negative areas, and then the absolute value makes them positive, right? So that's actually what the absolute value is doing. right? Like I said, as soon as you get an integral, just plug the integral in, right? Once you've broken the integral up into its intervals, you can just throw that into a calculator and get it that way. Otherwise, it's a little long to do by hand. Right? What we're going for here is, can you set up the integral? Okay, so I'm going to call it in about 30 seconds because we're approaching the 9-minute mark. Would it be legal to divide everything by x? Not if you're actually finding the area, no. Right? Like if you're trying to solve for x, maybe, if you'd already known that x was not 0. But if you divide by x, then you're getting rid of some of the height, right? And so you want to be careful about that. Yeah. Okay. All right, so we're a little bit split here. The correct answer is D. All right, so let's take a look. And like I said, this one, I'll actually show you if you want to check these ones. I'll show you how to do this in Wolfram Alpha in a second. All right, let's see. Okay, so here I've gone ahead and I've already plotted this for you. And, you know, of course, again, you guys are free to check the plot and kind of see what it looks like. But this is the graph of x cubed minus 3x squared plus 2x on the interval 1, 3. And again, you can actually, wait, why does this seem backwards to me? Did I plot that? I must have plotted that. Oh, no, between 1 and 3. Yeah, so this is between 0 and 3. And so you can see between 1 and 3, we're actually going to be negative from 1 to 2. And then we're going to be positive, you know, from 1 to 3. And we need to check that mathematically, but at least from the graph, you know, we've got some sort of idea that this is true. Let me try and draw that a little bit better. All right. Okay, so let's check it. So the first things we want to do is we actually want to find the roots of this function. And the reason that we're finding the roots is we want to be able to figure out where the function goes below 0 and where it's above 0, right? And the way that we're going to do that is we're going to find the roots, and then we'll set up a table and we'll figure out what, you know, whether the function is negative or positive there. So we're going to set x cubed minus 3x squared plus 2x equal to 0. And, you know, if we do all the work, you know, factor an x out of that, x squared minus 3x plus 2 equals 0. X minus 2, x minus 1 equals 0. So x equals 0, 1, and 2 are the roots. Okay, and again, if you were doing this in person and you didn't have access and weren't able to see what the graph was, at this point you would set up a table, right? So to tell where f is positive or negative, we use a table. And again, we're only interested on the interval 1 to 3. So I'm not going to worry about what happens between 0 and 1, right? We're not integrating there, so we don't care. So I'm just going to say 1 is less than x is less than 2, and 2 is less than x is less than 3. And by the same reasoning, we don't care about what happens if x is bigger than 3 because we're not integrating there. All right, x minus 1, x minus 2, f of x. And if we do this, okay, that's positive, positive, negative. So the function is negative, positive, positive, positive. So the function is positive. Voila, right? And that agrees with what I found in the graph. If x is between 1 and 2, our function is negative. And if it's between 1 and 3, our function is positive, right? Okay, so great. We know that. If we couldn't graph it, we now know. And so what we're going to do is we're going to say, all right, the integral from 1 to 3 of the absolute value of x cubed minus 3x squared plus 2, what is it? Plus 2x dx. So I'm going to split that into the integral from 1 to 2. Now, on 1 to 2, the function in the absolute value is negative. So when I drop the absolute values, I have to put an extra minus sign in front. Right? And then the integral from 2 to 3. Here on the interval 2 to 3, the function is positive. So I can just get rid of the absolute values and not do anything. X cubed minus 3x squared plus 2x dx. And then you go and you plug this into a calculator. And you get 1/4 on the first interval, 9/4 on the second interval. So that gives you 10/4 total, or 5/2, right? And like I said, once you get to here, this is, in these sorts of questions, if getting to here is the goal, right? Like there might be, if this question's out of 10, there's like, 1 mark here. Most of that is actually setting that up. On a test, we have to show the steps. I mean, Jude, it depends on what you're saying. I'd say like the work that I've done here is exactly the work that you should give as well. Or are you, no. You can say, we've told you you're allowed to use Desmos and Wolfram Alpha. So at this point, I would say like, buy Wolfram Alpha or something, right? To say that you used a computer in order to do this, make sure you tell us that, right? But yeah, you can totally say I plugged this into Wolfram Alpha and I got an answer. But yeah, this is the work you would show, and we really want to get to that integral. And if you get us to that integral, we're happy. So very quickly, let me show you how you actually do this if you were in Wolfram Alpha. So there's a couple of things that you can do here just to make your life easier. Let me get rid of all this stuff on my screen. Aside, I mean, we've said that calculators and computers are allowed the whole thing, right? Like anytime you guys want to use a calculator, an online calculator, that's okay. All right, so the first thing you can do is if you can describe your problem to Wolfram Alpha, that's great. Total area under x cubed minus 3x squared plus 2x on 113, right? Okay, let's see if that works out. All right, Wolfram Alpha's thinking.
It might give you the arc length.
Yeah, it did give me the arc length. Good call. Let me say absolute. I did this earlier, though. Actually, I just can't remember what I said. For 1 less than equal to x less than equal to 3. Maybe that'll work. You can't hear me, Kayla? Let's see. Did this work? All right. Screw Wolfram Alpha. The easier way to do this is to say the integral of the absolute value of x cubed minus 3x squared plus 2x on or from 1 to 3, right? And this should, for some reason, work. All right, and there you go. See, that worked. I mean, you do still need to know how integration works, but if you can imagine, we're never going to give you a question which is just compute this integral, right? Yeah, you got to know how to set it up. And the reason for that is, and I actually kind of agree with this even in real life, if you guys ever go out into the world and need to compute an integral, you're not going to do it by hand, right? There's lots of opportunity in real life where you will have to use an integral. Like, again, anytime you do statistics, you use an integral, for example. But if you go out and you do this in the real life, what are you going to do? You're not going to compute it by hand. You're going to go and you're going to plug it into a computer. So I think it's more important. You need to know how to set it up, right? Because a computer is generally not going to be able to do that for you. But once you know how to set it up, if you know how to plug it into the computer, that's great. And let's be real. In real life, that's the more important thing to know how to do, right? Let the computer do what the computer is good at. Let you do the part the computer's not good at, right? Which is setting it up. But you'll notice here, yeah, it actually did work out. We got 5/2. Can we go back to the answer real quick? Sure, absolutely. Right? So I start by finding the roots of the function, right? I want to find that it passes through 0 at 0, 1, or 2. But I actually don't care about 0, right? 0 is not useful to me because I'm integrating on the interval 1, 3. And in order to figure out where the integral is negative and positive, I create this table. Of course, if you can graph it, you can just look at it, right? And then you set up the integral like so. And again, you could actually split this absolute value in if you were plugging in this into Wolfram Alpha, but I'm kind of more interested in, can you get to this integral in the first place? Can we zoom out? I mean, there isn't more than that, right? That is the whole solution. Can I elaborate a little bit more on the table? For sure. Okay. So hopefully you all got, if you're taking picture or something like that, let me kind of zoom in on the table here and let's talk about what's going on in this table. So in this table, I'm trying to figure out where my function is positive and negative, right? So my function is, we know because I factored it, right? My function is x times x minus 1 times x minus 2. So in order to determine whether the function is positive or negative, what I want to do is figure out what are the signs of each of these three terms. If all three of these things are positive, then the function is positive, right? If two of these terms are positive, but one of them is negative, well, then positive times negative is negative, right? If one is positive and two are negative, the whole thing is positive, etc. So what this table is doing is saying, all right, let's look here. And let's say that I'm restricting our attention to the case where x is between 1 and 2. And what I'm going to do is say, okay, x, is this positive or negative? Well, let's take a number between 1 and 2. Let's say 1.5. We're going to plug it into the function x, and I get 1.5. Is that positive or negative? It's positive, right? Maybe I take x equals 1.5 and I plug it into x minus 1. What do I get? I get 0.5. That's positive, so I put positive. If I plug x equals 1.5 into x minus 2, I get negative a half. That's a negative number. So now I've figured out the signs of these three functions. And so I can multiply them together, and that tells me that f of x is negative, right? Oh, the integral from 2 to 3 was 9/4 by my computation, right? Right there for you, Olas. Right, 9/4. Maybe that looks like a over 4, but 9 over 4. Still kind of looks like an A. There you go. Okay, cool. Okay, sure. All right, cool. So does that make sense, everyone? You kind of see how you would do that? And then I made a promise to kind of explain more about this function thing from the previous question, right? Like, let's say that you have a function, f of x like this, and you had a function g of x like this, right? What we're kind of doing is, you can think of integrating as like summing these lines, right? Like summing this line here. And if you were to add up all the lengths of these lines as you integrated from the left to the right, that would give you the area. And so if I asked you, what is the height of this line? Well, you'd say this height is f of x, and this height, well, that height is actually negative g of x, right? Because g of x is going to be already a negative number because it's beneath the x-axis. So in order to figure out what the length of that is, because we want our lengths to be positive, it actually has to be negative g of x. And so the total length of this line would be f of x minus g of x, right? And that's why you actually don't care about what parts are beneath the x-axis, because the minus sign is already going to account for that relative difference, right? And that's kind of the important bit there. Right? And I think many of you guys could do that. Like if I said, here's f of x and here's g of x, like what is the length of this line? You would come to this answer, right? So it doesn't become like negative g of x. No, because there's already two. Like this is negative, or this is g of x right here, right? Like that is by definition g of x. And it's already negative because it's beneath the x-axis. So throwing another negative sign in it is what makes it positive in the first place. Okay. And those were some direct messages for people, just in case you're kind of wondering what was going on there. But yeah, okay. So hopefully that makes sense, and you're good on that. Okay, let's pick up another one then, if everyone's okay with that. All right, yeah, let's do this. Okay, and kind of like bonus question, I know, oh, you know what, let me relaunch the polls. But bonus question before anyone, and you don't have to answer, if I didn't say the absolute area, what would the answer be? If I just said find the integral from -2 to 2 of this function without doing any math, what's the answer? Okay, Chifeng, why? Okay, so right. Okay, so there's some things here. No, Olis, don't second guess yourself. You're right. Right, and Hasem, so you're recognizing there's a symmetry here, so it's either 2 times or it's 0. Okay, yeah, it's an odd function, right? Everyone, this is an odd function. We'd be integrating from -2 to 2, which is a symmetric interval, which means that the areas would cancel each other out perfectly, right? And so we'd get 0. And Tina, exactly, that's kind of what you said, right? So right, this would give us 0. Now, the important point here is, of course, that I'm not asking for the just the integral. I want the absolute area, right? So that's going to change this in a useful way. All right, there's still symmetry here, but the symmetry is not odd symmetry anymore. Right, so what does it become? So instead of odd, it is now, right, Chifeng, exactly. Mm-hmm. Mm-hmm. Well, if it's an even function, what is an even function? The original function that I gave you? So you'd still have to do it. You could say, so here's the thing, the absolute value, and you guys can check this yourself, the absolute value of an odd function is even, and the absolute value of an even function is even. So what that means is when you take the absolute value, it converts those symmetries. It's not that the absolute value of everything is even. That's not true. But the absolute value of an even or an odd function becomes even. So when we do the absolute area, you can use that symmetry in order to help you out. And so you can say, listen, the integral from -2 to 2, the total area from -2 to 2 is twice the total area from 0 to 2. And then compute the total area from 0 to 2 using your usual thing, right? Where you determine where it's positive and negative and so on. Yeah, same steps. Is it possible you make it symmetric from -3? Symmetric from -1 to 3 by horizontally translating it 1 unit to the right. Yes. Yes. Oh, so that's actually, okay, you're getting onto something very interesting here and very clever, which is what does it mean to be symmetric about a point that isn't the y-axis, right? So what you're kind of, I think, hinting at is saying, like, what does it mean to be even or odd about the line x equals 1, right? Because you've translated 1 unit to the right. And yes, absolutely, in those cases, you would still get an integral of 0 or 2 times the integral from 1 to 3 or something like that. But it is a little bit harder to define what that means. Yeah, it's not. And it's definitely not easy to see from the function itself. You know what I mean? Like, I can look at the function that's on the screen and be like, oh yeah, that function's odd, right? The thing in the bottom is always, it doesn't, you know, it's even. The thing in the top is odd. And so the combination of these two things is odd. But if you're looking at symmetric about the number 1 or 10 or pi or something, it's really, really hard to see. And in particular, even think about taking this function and translating it 1 unit to the right. That amounts to putting, everywhere you see an x, put an x minus 1, right? And if you do that, the problem is that, okay, if you were to write it like that, you might be able to see it. But if you were to take the x minus 1 squared in the denominator and expand it out and collect like terms with that plus 1, now it's really hard to see, right? It would become, here, let me put it in the chat. What would it become? X squared minus 2x plus 2. Oh, sorry, I sent that as a private message. Right? And yeah, at that point, like, you have no idea that that's symmetric about 1. Yeah, right? And so you really lose the ability to see that symmetry now. So you can still do it. And this is where being able to graph the function is really, really advantageous, because you're like, oh, hey, look, there is a lot of symmetry here. But yeah, no, that's a great idea. So especially if you can see that symmetry, if you were to graph it and say, listen, I could actually just kind of shift this back to the left and do the integral there, then I'll get the right answer. And that's phenomenal. And you can actually do that. If you do that on a test, though, make sure you say that, right? Be like, I see that this function has a symmetry about the line x equals 1. So computing the area would be the same as computing the area of this function. And this has an obvious symmetry that we can exploit, right? So you'd say something like that. So we actually have a function like that coming up here. I'll try and see if we can do that one next, and I'll show you exactly what I'm talking about. But yeah, that's exactly it. That's a great idea. And it's nice and clever that you saw that. Yeah. I mean, so you would substitute x plus 1 everywhere, right? Like, that's how you shift functions to the left or right. You plug in x minus a is a shift of a units to the right. So x plus a is a shift of a units to the left. And if you took that function that you plugged x minus 1 into and plugged in x plus 1, it would re-simplify into a much nicer version, right? And that's how you would do it. Jivang, you're saying this question didn't take too long? Like, you managed to grind it out pretty quickly? Yeah, okay, that's great. And yeah, a lot of people, I think we've already got a fair number of votes this time versus last time. So that's good. No, that's okay. That's fine. I mean, again, it's important to remember that a big part of this model is no, it's okay. So, like, you know, remember what I say. The purpose of the way that we're doing this class is that you guys aren't paying for a concert, right? You're not paying for me to stand at the room and entertain for you. That's not useful, because then I could hire somebody off the street to do that, and they'd probably do a better job. Maybe they'd add some juggling in or something, and you'd be captivated by it more. And you'd be like, this is awesome. The what you guys are paying for is access to me and the ability to ask me questions. And so the reason that we do things this way, sure, I know I'm a pretty good lecturer, but okay, but imagine, you know, your generic, like, least favorite econ or philosophy prof or whatever. And, you know, you could probably imagine that you could hire a drama student who would do a better job of presenting the material if all they had to do was write the things on the board or go through slides or stuff like that, right? So the point of this is for you guys to have access to me. And why I want you to do these questions is so that you have this practice of going through the question, getting stuck, and then being able to say, I don't know how to do this. I got stuck. Can you help me get over my bumps? Right? And that's the entire point, is that I want you all to be able to make mistakes here with me around so I can answer your questions, right? And so, Olas, what I'm saying is, in this case, if you didn't do this question because you were so busy answering, like asking me good questions, that was kind of the point anyway, right? It's like, I want you to do these questions, these problems, so that you figure out what questions to ask. But if you already have good questions to ask, then that's phenomenal, right? Like that is already kind of the point of doing these things. And if that helps you go and do this question on your own, then it doesn't matter whether you did it here, because I was able to answer your questions ahead of time. You can now go and do this problem on your own, and phenomenal, you can get it. And we achieve the same thing, right? Sure. Any question you ask is the right question, right? Which is, it's, I guess it's, you know, a cliched version of, you know, there are no dumb questions to ask, but it's like literally what I want you guys to do is ask questions, right? That's why we're doing this. I'm going to close the polls, by the way, in like 20 seconds here. So if you want to get something in here, do that. Is this a right question? Are you asking that question about this question? Because if so, that's very meta and self-referential, and it's beautiful, but because if the answer, in fact, Abdurrahman, maybe it's possible we'd have to think about this, but you might have just asked a paradox, right? Which is, if it's not the right question, then how can it be the right question? Do you have an example of a bad or wrong question? No, Christine, like there's, my point here is, again, and I think I've been very clear that it doesn't matter kind of what question you guys ask, I'll take it seriously, right? But if okay, you know what a bad question is? I'll tell you guys an example of a bad question. There are people, and I'll take this up in a second, but let me just go off base a little bit here. There are people who ask questions in class to flex, you know what I mean? To like flex on their classmates, to be like, you know, I've gone and I've, you know, done, you know, a lot of reading ahead of time, and the only reason I'm asking this question is to like show off to people that I've done stuff. And it's not to say I don't want you to ask questions that are interesting or that go beyond the material. I totally love that, and I encourage you all to do it. But if your reasons are malicious, that like you either already know the answer or you're just trying to make your classmates feel bad, that's a bad question, right? Exactly. And I know that those people exist, and you know, I do usually take those people aside, and sometimes they're not even doing it to be a jerk. It's just, it's how they feel good about themselves, and I have to be like, listen, I know, you know, you're a good student, you've read ahead, and that's awesome, but don't do that in class, because you know your classmates are going to hate you, and you have to be with these people for the next 3 years, and the last thing you want is for all of them to hate you, right? And usually they're like, oh yeah, you're right, totally. And I've legitimately had that conversation with a student, right? Like, she didn't realize that you know, sometimes she'd be like, oh, this was a really easy thing or something like that, and it just made everyone in the class kind of glare at her, and she wasn't paying attention. I had to take her aside and be like, listen, I know you're not doing it to irritate other people, but you just got to be careful about what you say, right? Because these are going to be people who you need to rely on for help in future years. Just, you know, don't step on toes and stuff like that, right? And exactly, Abdul Rahman, that's a great way of questioning it. There's no wrong questions, only wrong reasons. Right? Exactly. The know-it-all people, right? Yeah, if you're asking about me, I mean, we kind of go tangent in this class. You guys know that, and I don't mind doing that. But yeah, if your reasons are bad reasons, it's a bad question, right? Not because the question itself is bad, but because the reason is bad. But otherwise, like, please ask me any question that you have. I do not, it doesn't matter. You know, if you're struggling with something very simple, I've had students be like, hold on, you know, and it's a little embarrassing for them, but they were like, you know, my fractions are really bad and I'm having trouble seeing how you did, you know, this fractional rearrangement. I'm happy to go over that, because it's not worth you sitting there not knowing how something worked when I could clarify it for you with 5 seconds worth of stuff, right? And so I want you to ask those questions, right? Okay, so let's see. So let's kind of remind ourselves what was the question. So we had this function. We had f of x equals x over root x squared plus 1. And we were looking at the interval -2, 2. And we want the total area, right? Now, if you graph this thing, it looks, if I recall, it looks something, you know, like this, right? This is what the graph of f of x looks like. Okay, and as we were saying, it's definitely an odd function, but we actually want to be able to integrate its absolute value, right? And if we integrate the absolute value, it becomes an even function. So note that, and you don't have to do it this way, okay? I'm just, you know, when I kind of gave you all this hint, is that when you take the absolute value, notice that the absolute value of the denominator doesn't change because the square root is already positive, right? We always assume that the square root is positive. And so the only thing that I did was take the absolute value of the numerator, and now everything is even, right? So with everything being even, great, this is an even function. And what that means is, so we have that the integral from -2 to 2 of the absolute value of f of x dx is equal to 2 times the integral from 0 to 2 of just, well, you know, frankly, of just absolute value of x root x squared plus 1 dx, okay? And again, I need to emphasize here, this is not, it is, Chifeng, it is, f is odd, okay? This function is odd, right? And if we were to integrate that, we would have gotten 0. But we're not integrating the odd function, we're integrating the absolute value of the function. And the absolute value itself is even, right? Like think about, here, let me draw the absolute value in that same graph in the top hand corner. The absolute value looks like that, right? And so now is an even function. Okay, yeah. And so this is important. Make sure, so when you take the absolute value of a function, you're not guaranteed to get even or odd. But if you started with even or odd and you take the absolute value, you get an even function, right? What if we split it and multiply the first part by 2? I mean, that is actually effectively what I'm doing, Jude. So what I'm going to do here, let me just write out one more line here. So the absolute value of x on 0 to 2 is just x, right? And I think, Jude, that's what you're saying. And it's true, I kind of went in a, you know, maybe a long path to get there, or I kind of like, you know, did this extra step, but that's basically what I did, right? Is said, look, I can split this into these two integrals. And if you guys don't want to use the absolute value, you don't have to. You can be like, by inspection, clearly the area on the left is the same as the area on the right, except one is negative. So let's just compute the area on the right, multiply it by 2. That's totally okay. Make sure you include a sentence saying that though, right? Or something along those lines. How do we know when to use the absolute value rule? So Kevin, as a general sort of thing, like if you're doing, anytime you're computing absolute area, like the total area, the answer is use the absolute value. Okay, actually, let me kind of comment on that in a second. I made this comment a little bit in the video, but let me make it a little bit more. But let me finish this one first and we'll go over it. Do we have to show how we knew which parts are positive and which are negative? Or is it fine to say we use Desmos? I'd say it's okay to use Desmos. I'd say that's okay. You do technically have to be a little bit careful. So what I want you to do, you know, in the last question we did, this one here. Now we'd already found the roots, right? We'd found that the roots were 0, 1, and 2. And so now we can say by Desmos, I know that I'm positive between 0 and 1, negative between 1 and 2, and positive between 1 and 3. Now, the thing you have to be careful about, though, if you want to use Desmos, is that if you don't know that you found all the roots, maybe it's the case that there actually is, you know, if you were to really zoom in on the number 1, that actually it did, oh, yellow is a bad color there, that maybe it actually did something like this. Do you know what I mean? And you actually missed that the function went from positive to negative, and you just didn't see it because you were so zoomed out from the graph. But if you know that the critical points are 0, 1, and 2, and you graph it and you say by the graph, I know it's positive here or negative here, that's okay. right? I don't know if that seemed a little too technical, but you're saying because I know the critical points, I know that it couldn't possibly have switched, you know, and I just didn't see it, sort of thing. Okay. And the last thing we have to do is we actually have to solve this integral. This is definitely going to be a substitution. So I'm going to set u to be x squared plus 1 so that du is 2x dx. And again, doing the substitution, I'm also going to change the bounds, right? So u of 0 is 1, u of 2 is equal to 5. And if I do that substitution, so I'm going to get 2 times the integral from 1 to 5 of 1/2 1 over root u du. The 2 and the half cancel out. So I'm going to get 2 root u from 1 to 5, which is 2 root 5 minus 1. And that was B. Yeah, or so Chifeng, you don't have to change the bounds if you change it back to x, okay? So if you get to here and you change it back to x, you can change it back to the original bounds, right? You get the same answer. But if you want to evaluate it in u, right, as a function in u, you have to figure out what u is at the upper and lower bounds of the integral. If you change it back to x, you can use the original bounds, right? Okay, sure. So I got a direct question saying like, how did I see that this function is odd or even? Totally okay, let's talk about that. So, all right, so remember, even function does this, right? So this is even. And definitely, I think there are probably some other people who will benefit from this. Even if nothing else, kind of, you know, the fact that I'm recording this lecture, it'll be nice to, for people who want to be like, oh yeah, how do I do that? And they can come back and look at this. Okay, so if it's even, then when I plug in f of negative x, I should just get f of x out. If it's odd and I plug in f of negative x, I should get negative f of negative x out, right? And some functions are neither, right? So let's keep that in mind. Not every function is odd or even. Some are neither. So what I'm going to do to test if this function is even or odd, I'm actually going to plug in negative x, right? And if I do that, I'm going to get negative x divided by the square root negative x squared plus 1. Now, negative x squared is the same thing as just x squared. And so if I pull, well, maybe let me leave that minus sign up here for now. Right, and then I'll pull that minus sign out. Like that. And that is negative f of x, right? Oops, sorry, this should just be f of x. Being silly there. Okay, and that's how we check that it's odd. Now, again, for me, I can kind of eyeball it. I see that the numerator is odd, right? Like x is an odd function. And I see that the denominator is even because it only has even powers of x, right? X squared. And when you get an odd function times an even function, that function will be an odd function, right? And you can always kind of check that. Can we say by inspection? I would say yes. Yeah, so hey, but I mean, of course, if you're going to say that, you have to be, well, yeah, even if you take the absolute value and odd in this case, yes, I would say that you can say that by inspection, but you got to make sure you're right. You know what I mean? Like if you say that and you're wrong, then you're going to be in for a world of hurt, right? So it's the sort of thing that when you're writing it, I am okay for you just to declare something as even or odd, but again, make sure you're right about that. You know what I mean? Okay, so let me zoom out here, see if I can give you the whole picture there. Okay, so direct messenger, does that, the person who asked me that question, does that help clarify how I figured out that that function was even or odd? Okay, cool. Right, and again, with a little bit of practice, you can just see it, right? You get used to seeing, oh, this function is even, this is odd. It might take a bit to get there, but if you practice it a bit, it comes quite naturally, right? Especially when things are built up of polynomials, look at their powers. If they have like mixes of evens and odds, they're probably not. But if each of the components separately are only even or odd, you can do some stuff. Can we go back to the question for a second? Sure. Yeah. What is there something Do you mean the previous question or talk about this one? Okay, sure. What about this one? Because I'm done, right? I found, no, I know, but we're done. Right? We got 2 root 5 minus 1. No, but it's on the screen. This is the whole question. Oh, the slide. Okay, the slide. I see. Sorry. I didn't quite understand what you're saying. I understand. I get it now. There you go. I mean, like, no, don't worry about it. Like, Sana obviously knew what you were talking about, so it must have just been me. And again, these will be posted though later, though, right? So if you're like taking a picture of something like this, don't worry about it, because I'm going to post this in a second. Okay, everyone's okay with that? Because if so, I'd like to go to the next one to kind of highlight something that Olis was talking about in terms of this like shifting idea, which I really, really like. So we have a question on that, which I think would be a nice one. So again, for those of you who maybe want to go and watch next week's videos or whatever the case is, of course, you don't have to stay. But I do have one more question that I'd really like to do if you know, you'd be willing to hang out. Can I zoom? Sure. Well, I mean, Christine, you know, if you can get your lunch and you can eat it, then it can work as well. I'm kind of confused of which parts of the answer we need to show in a test or assignment. In the first question, we did not show the steps of integration. We used Wolfram Alpha, but in this one, we did. Yeah, that's true. Okay, so Jude, that's an absolutely fair question. In this case, I would again say that it is okay for you to plug that into Wolfram Alpha. What I wanted, the reason why I did this one by hand though, is because it's a substitution problem and I wanted us to have a little bit more practice doing the substitution. So you're absolutely right. That is a great point. Why did I do this one by hand and the other one I just plugged into Wolfram Alpha? But I really, really wanted us to practice the substitution, right? If that makes sense. Okay, so that was the idea behind why I did this one by hand. Yeah, it's just good practice. You know what I mean? Just like with the other one would have been good practice to do it by hand, but I think that most of us are probably okay integrating polynomials anyway, right? Whereas this one is substitution, which is a little bit newer to us and we could use a bit more practice on. So, you know, I just wanted to do that for practice. Okay, so like the ones where, yeah. Okay, so let's do, here's another question. Now this one might be a little bit on the tougher side. What was the answer that we need to include? So the question was, in this question that I just did, Olis, I did the substitution by hand, right? We set up the integral and I did it by hand, but in the previous question I'd said, once we set up the integral, just plug it into Wolfram Alpha. So the question was, why didn't I just plug that into Wolfram Alpha? And I was saying for teaching reasons, I wanted us to practice substitution a bit more, but you absolutely could have plugged it into Wolfram Alpha if that was a test or something. And so there was just some confusion about when are you allowed to do it by hand and versus using a computer. All right, this one's a little bit trickier. So, you know, work with this one a little bit carefully. Exactly, Olis. You'll have something probably with F's or G's. Now, that being said, actually, there was a question on last week's polls. Let me see if I can find it, just so I can really point you to it, because it was a question on last year's final that we didn't do that I don't think Wolfram Alpha can do either. Maybe Wolfram Alpha can do it. I'm not 100% certain. Like I said, let me see which one it was. No, is this week 9? This week's week 9, right? Yeah, okay, last week was week 8. Okay, so slide 15, I'm gonna put this in the chat. So week 8, slide 15. So this was a question either on last year's final exam or on term test for their term test 4. And their term test 4 was the first test after we went into lockdown, right? So it was a remote test. It wasn't an in-person test. This question, I'm not certain Wolfram Alpha can do. I might be wrong, but I don't think Wolfram Alpha can do it. But that, despite that, it doesn't have any abstract functions in it. Like everything there is very well defined. So there isn't like, here's a function f and here's its values at points, but you still kind of need to do it. Yes, yeah, Chifeng. I think this was on last year's final. So I strongly recommend that everybody give it a try just to see that if you can do it. And of course, it wasn't multiple choice, but give it a shot, see if you can do it. And of course, if you can't do it, you know, throw something up onto Piazza or ask me during lecture. I'll be happy to do it, right? Haysom, you don't have to, and I can show you how we could do this without. It's kind of your call if you want to do it, but. So I would say there's a conservation of work here, everyone. So I was actually just asked a great question, which is, you know, without giving too much away. Okay, so now a couple of people have asked it. Do we have to integrate this function in y instead of in x? And the answer is you can. Okay, in fact, the natural setup of this question is to integrate it in y. But you don't have to. And if you're clever about it and use something that Olis kind of was mentioning earlier in the class, then it's actually much easier to do to integrate in the x direction, but you have to do something tricky first. All right? Sure. I mean, you know, give it a try, see what happens. But like I said, I'll show you how to do it. So integrate it however you like. You'll get as long as you do the right way, you'll get the right answer. But I'll show you how to do it in the clever way when we're done. Oh, I didn't open the polls. Let me do that. Wait, why is it not? What's going on? Okay, there we go. Relaunch. That's a great question. How do we know whether to integrate with respect to x or y? It's going to really depend on the question. Maybe remind me to pick that up once I've gone through this, and I can give you examples. I can like just draw some examples. Yeah, definitely sketching the graph is going to help. Often what it comes down to, there's no reason to usually integrate in one direction over the other than the fact of how simple or how complex your integral is going to be. Okay, and if you actually, you know what? Maybe I can find a textbook question for you that really illustrates it, where I think I do it both ways. So just give me a second here. Let me see if I can find it. Okay, there we go. It's example 9.7 of the PDF notes. All right, and in example 9.7, do I set it up as an x direction? Let me see. Okay, yeah, so I'm going to point you to example 9.7 now. Why don't we finish this question, and then I will show you, if you wanted to do 9.7 in the x direction, how you would do it. Okay, because I thought I did it in the book, but I guess I didn't.
I feel like you go into more detail on the importance of order of integration in the multivariable part.
Yeah, it could be. Yeah,
like you have some heinous ones in there.
Mm-hmm. Including this one, actually. This one shows back up again.
No, that doesn't surprise me.
Yeah, yeah, for sure. And yeah, plugging this one into something like Desmos, I think is really going to help you. This is the sort of thing I can graph this because I know what the graph of like y equals x to the 2/3 looks like. And so I can graph this. Some of you might not be familiar with that though. So this might be something you want to plug into Desmos just so you can visualize it a little bit better. Mm-hmm, mm-hmm. Yeah, you definitely want to be able to graph these, which, think about it. This is a fairly major, serious advantage that you all have over the in-person people. This particular question might be too hard for us to give in person without giving a graph of what this thing actually looks like. But in the in-person years, we would give you curves and we wouldn't necessarily sketch them for you. And so you had to figure out what the curves look like, right, in order to be able to visualize it. And you guys don't have to do that because you have the ability to graph it. By the way, I want to emphasize here, for those of you who do eventually set up the integral and plug it into Wolfram Alpha, Wolfram Alpha will probably give you the wrong answer. So I don't know how many of you have done that yet, but Wolfram Alpha will give you like a complex number and you're like, hold on, what? That's nonsense. So you can see it is actually still possible. So there's two really things that I want to emphasize here. One is what Olis was talking about earlier with the shift thing, and I'm going to point that out to you. And if any of you get it, that's phenomenal. And two, that it is possible for us to give you explicit functions that Wolfram Alpha can't do, right? That even if you set up the integral correctly, Wolfram Alpha won't know how to do it. If you can graph it, Olis, I think it's a lot easier.
I actually have the relevant term test here. The graph that you had us find the area between two bounds is super simple.
Okay, so yeah, maybe I was really nice. What were the functions?
X squared minus 2 and y equals x.
X squared minus 2. Yeah, that's pretty nice. I guess we were feeling pretty generous.
I mean, I think the average on this test was still like a 55.
I mean, that's just the way it is. Yeah, Haysom, you probably don't want a negative number. That's the right number in absolute value, but your signs are wrong. So you've got a minus sign in the wrong place somewhere.
Then again, if I had to guess looking at this, people probably messed up on the improper integral part.
Mm-hmm, mm-hmm. Well, so you should expect to get questions on polls and assignments that are harder than things you would see in a test, right? And I think that is both fair and expected. And I actually think that we've been consistent with that all year, right? I think your tests have been easier than your assignments as a general rule.
They kind of have to be because of the time constraint.
Exactly. Yes, but also you also have like
I mean,
2
I think
weeks
assignment
to work
averages
on
tend to be higher.
Yeah, they always are, right? And the assignment averages are always like 80 to 95% range, and the tests are always like 60 to 70. That's always what it is. Chifeng, no, you made a classic mistake, which is why that is there. You're close. You're close. Okay, I'm going to wrap this up in about 30 seconds here so I can show you the answer, because I think we've been going pretty long on this one. Probably 11 or 12 minutes. It's a harder question, but yeah, maybe. Yeah, I think you computed the opposite area. I think you computed like the other bound, right? So you're off by exactly the right number. Yes. Okay. So here are our results. We're fairly split. But interestingly, the thing that has the right or the most number of people, B, is the right answer. So 4/5 is absolutely correct. Yeah, you were hitting the button as I kind of ended it. Okay, so B is the correct answer here. And let me show you why. All right. Share. All right. So there's a bunch of stuff we have to do. This is actually a fairly involved problem. But okay, so let's see. What do we want to do here? So we've got x cubed. So I'm going to kind of set this up the standard way to begin with, x cubed, and then I'll show you the nice little trick. Y minus 1 squared and x equals 1. Okay, so I can graph this. I know, okay, this is the sort of thing that I would let you guys just kind of graph in Desmos, but I know that the graph y equals x to the 2/3 looks like this thing, kind of like if you were drawing a bird in a really bad bird in a drawing, it would look something like that, right? Yeah, exactly. It's a seagull, right? So what that tells me is if I want to draw this, what I'm going to do is I'm actually going to rewrite this as x equals y minus 1 to the 2/3. And so what that says to me is it's going to look like the seagull. If it was just y to the 2/3, okay, I'm going to erase this in a second, so don't copy this down if you're doing it. If it was just y to the 2/3, it would look like this. But because it's y minus 1, I have to move it up a unit. Okay, so this is x equals y minus 1 to the 2/3. Right, and then x equals 1 just looks something like that. Right, and so what we're after is this thing right here. Okay, so that's how you do that. And again, if you're trying to figure out like why did y minus 1 move it up 1, because remember, if you want to move things to the right, what do? You replace it with x minus 1. So if I want to move things up, what do? I replace it with y minus 1, right? And if I want to move them down, I'd replace it y plus 1. Okay, so it's the same sort of thing, because up is to the right if your y-axis, if you drew your y-axis in the horizontal. How do I know that x equals 1 is inside the x-intercept? I don't. Chiefing, I have no idea. In fact, it isn't, right? X equals 1 is exactly the intercept. But at this point, I'm just trying to get a rough idea of what the graph looks like, but it actually looks like this, right? I'm just trying to get close. It actually hits the x-intercept perfectly. Okay, so what I'm going to do is I want to find these points right here. Okay, I want to find this point, and I want to find this point. This point's not too bad, right? This point is 0, 1, right? If I plug x equals 0 into this equation, and I solve where does y minus 1 squared equal 0, the answer is 1. So I need to find these 2 points. So what I'm going to do is sub x equals 1, because that's one of the curves, into x cubed equals, let me put that on the lower line, x cubed equals y minus 1 squared to get 1 is equal to y minus 1 squared, right? And there's a bunch of ways that you could solve this. You could expand the right-hand side out, collect it together, get a quadratic, whatever. I'm just going to take the square root of both sides. So you get plus minus 1 is equal to y minus 1. So if I add 1 to both sides, y is equal to 0 and 2. All right? So this is the point 1, 0, and this is the point 1, 2. Okay? And so at this point, maybe I had drawn it wrong originally. I'm going to erase it and kind of reshift my line over so it looks like that. So this is what I'm after. It's this weird like triangle thing, this warped triangle thing. And this is the area I'm trying to get. Now, a couple of people private messaged me saying, hey, should we integrate in the y direction? And absolutely, I think that you should. There's a couple of ways that you do this. Let me show you how you would set up these integrals. So with this in mind, if we integrate in the y direction, I think this is the easiest way. Our goal is to make y equals 0, not necessarily. So person who direct messaged me that, where do you think I was doing that so I can clarify it? No, I plugged y. Okay, when I got y is equal to 0 and 2, that was me plugging x equals 1 into my equation to figure out where my vertical line, x equals 1, hit this weird like sideways seagull, right? That's what I was trying to do, is find where did the sideways seagull hit that vertical line. Wants to find the x-intercept. You could do that if you wanted to. Again, it may be useful. It might not be useful. It kind of depends on what it is that you're trying to do. Generally, though, finding anytime you've got a region bounded by two curves, you want to find the intersection of those curves, right? And so that's what I'm trying to do here, is I'm trying to find the intersection of the green vertical line and the sideways seagull. Right? No, it could be important. It absolutely could be important to find the x-intercept. It's just, in this case, I think it's more important to find the intercepts of the curves, and it just turns out to be the same, which is nice. But yeah. Okay. Okay, so if we integrate in the y direction, and I'll tell you why we might want to do that. Integrate in the y direction. The reason that I'm going to do that is there's one function above the in the y's, and there's one function beneath. Here, let me show you what I want. So the integral then is the integral from 0 to 2 of 1 minus y minus 1 to the 2/3 dy. Okay. So if you integrate in the y direction, this is what you get, because the first curve is the curve x equals 1, right? This here is the curve x equals 1. And this curve here is the curve x cubed equals y minus 1 squared. But I've had to solve it for x, right? Does that make sense? So I've got two curves here. One curve is always on top, and the other curve is always on the bottom. But like, turn your head to the sideways, right? Like, turn your head to the right. So you're looking at it. This is kind of weird, right? And especially if you're looking at me in the video, I'm sure I look quite silly. But you turn your head to the right here, and you're staring at this graph, and it's the same thing as, if I had drawn, something like this. Right? Okay, so hopefully you can see why. Can we switch back x and y in the original question? I would say you could, Abdul Rahman, just make sure you say that when you're doing it, right? So Abdul Rahman, what Abdul Rahman is asking is, can I just like basically write it in terms of, switching the x and y's and then visualize it as this graph? Absolutely. Just make sure that you say that in your, say that in your solution. That's totally fine. And yeah, this is, all of you have your videos off, so I didn't actually get to see you doing this, but in an in-person exam, the best is anytime there's like geometry involved or vectors or anything, and you get to like watch the entire class as they're like trying to like maybe do the right-hand rule or trying to visual, and they've got their paper up and they're like turning it sideways. And you just look out at a room of like 500 people, and everyone in the room is doing something sort of ridiculous in order to visualize it. It's beautiful. I love it, right? Okay, so anyway, you can go and you can work out this integral. If we couldn't graph, how would we know which one comes first? That's a great question. What you could do is plug in values of like x or y into your curve and see, are they bigger or smaller than 1, x equals 1, right? So for example, if I plugged in, it's hard to find a nice value here, but if you plugged into this top equation here, I don't know, y is equal to, a half, and you solved it for x, you'd be able to figure out that in fact the x value was less than x equals 1, right? In kind of like very much the same way, if I gave you two functions, f of x and g of x, how do you figure out which function is bigger? Well, you just plug numbers in. Once you know where these two functions meet, you plug functions in and see which function is bigger in that interval, right? Yeah. Okay, so you guys can work this out. And this one, I think somebody, actually, this would be a great exercise. I would love for all of you to go and plug this integral into Wolfram alpha, right? And tell me, what does Wolfram alpha give you? Here, maybe I'll do it. And then we can solve it by hand, right? It's a fairly easy integral to solve. But let's see what Wolfram alpha gives us. Integral of 1 minus y minus 1 to the power of 2/3 from 0 to 2. Yeah, and I'm doing my right, like that's crazy. See, Luke? But okay, so it gives us, first of all, it gives us 69ths. Oh, sorry, wait, oh, it thinks I'm dividing by 3, so I should put that in brackets. Right, what the heck is this thing? Right, look at this thing. What the heck is this? This is a complex number, right? Look at that, that's nonsense. Right? We know whatever this is, it's a real number. Why is it giving me out complex numbers, right? Yeah, so the problem here is the 2/3, okay? Wolfram alpha sees 2/3 and it instinctively will try to write 2/3 as e to the 2/3 ln y minus 1, right? So when it sees y minus 1 to the 2/3, it writes it as e to the 2/3 ln y minus 1. And then if you plug in negative numbers into there, it freaks out and it gives you complex numbers out. So this is an integral that's actually pretty easy to do by hand. Wolfram alpha will give you the wrong answer. Okay, so you have to be careful about this sometimes. Just because you get a weird answer here doesn't mean that your answer is wrong. It just means that computers suck sometimes. Okay, and if you were to actually do this here, let me show you how you would do this by hand. So let me say I wanted to integrate this. So first thing I would do is split it up. Y minus 1 to the 2/3 dy. So this, and the reason I did that is because the integral of 1 is very easy, right? Now, if you don't know how to do that integral y minus 1 to the 2/3, what we're going to do is we're going to do a substitution. Okay, so I'm going to let just, this isn't necessary, but I think it really helps you see what's going on, right? And then u of 0 is -1, u of 2 is 1. And so this integral then becomes the integral from -1 to 1 of u to the 2/3 du, right? Okay, yeah, some calculators might do it correctly, some don't. The problem, so the actual issue here is that Wolfram alpha is probably more powerful than both of those two things. So it's capable of doing complex integrals and those sorts of things. So when it sees that, it automatically assumes it's a complex integral. Okay, so 5/3 u to the -1, sorry, 3/5. What am I doing? 3/5 u to 3/3 -1 to 1, right? And actually, I know that this is an even function, so that's going to give me 2 minus 6/5. So that's 4/5. Okay. How do I get 2? Yeah. Could I please zoom out? Sure. And then I'm going to do this another way that might make your life a little bit easier. So Selena, did that work out? Or like, are you asking about this 2 right here? Yeah, so I think Jordan's answer covers it, right? But the integral from 0 to 2, first of all, you could do it, you could just think about it in terms of a graph, right? What's the integral of 1 on the interval 0 to 2? Well, that's a rectangle, right, with area 2. Or the integral of 0 to 2 dy is just y evaluated from 0 to 2, which is 2 minus 0, which is 2, right? How do I know that x equals 1 is bigger than? So the same way, if you want to check, so how do you check that one function is bigger than another? You figure out where they meet, right? And we found those intersections. And then you plug numbers between those into the graph, right? Here, once I do this, I will go back in a second. But Olis, are you good with this? Can I go back? Or do you need me to talk about this more? Okay, cool. So how would I do it without the graph? So without the graph, what I would say is, listen, we know that x is equal to y minus 1 to the 2/3. So if I plug in y is equal to some number like 1/2, then I would get 1/2 minus 1 to the 2/3. And somebody can work that out, whatever that number is. The cubed root of a quarter, some number. Yeah, it's whatever it is, it's less than 1. Right? And that's how we knew that this function was less than x equals 1. Does that make sense? Yeah. Okay, so let me show you all the other way of doing this, which is, again, Olis's like really clever way of doing things that he was talking about earlier. Let me pull it in. We're subbing in a number between 0, 2, and 0 for y. Yes. Yeah, exactly. Yeah, and so that's why I chose 1/2. Okay, so let me redraw this. Okay, so we've got our sideways seagull. And then we've got x equals 1. Okay. Okay, sure. But okay, listen, let me put it like this. So everyone hopefully agrees. So we've got this kind of weird curvy triangle thing here. And it would probably be a lot easier to do this question if it looked like this. Right? We notice that there's a lot of symmetry in this question, right? It seems to be perfectly symmetric about the point y equals 1. Right? It actually looks like it's an even function about the line y equals 1. So Olis's idea was to take this thing and basically move it down so that it is now symmetric about the x-axis, and now to do the integral. So let me show you how we can do this now. What we're going to do is we're going to sub y plus 1 into the curve. Okay, so y plus 1 is going to move it down. Yeah, right? We're moving the curve down, so you got to do y, right? You got to move the y this time. And look at what happens. So if I get x cubed equals to y plus 1 minus 1 squared, which is just y squared. Right? So we get x cubed is equal to y squared. So now you can do this one in either the x or y direction. And this one's actually easier to do to integrate in the x direction, right? So if you want to do it in the y direction, okay, so you could do this as the integral from -1. So this is now -1, right? Because we just moved everything down by 1. -1 to 1, 1 minus y to the 2/3 dy. And you'll notice that we'll get exactly the same integral that we got above, right? Or we could say, look, this function is even. So it's 2 times the integral from 0 to 1 of y to the 2/3. Sorry, y, 1 minus. Or if you just wanted to do it in the x direction, well, this is y is equal to x to the 3/2, right? So then this would become the integral from 0 to 1, 2 times the integral from 0 to 1 of x to the 3/2 dx. Right? And the 2 is because when I integrate it, I only get the top half. So I'm going to multiply the answer by 2. Yeah, exactly, right? The area doesn't care. This is a great point, Shifang, that you kind of bring up. The area doesn't care about whether, where the actual shape is in the plane, right? You can move it wherever you want, and the area between those curves is going to be the same. what happened to x equals 1? X equals 1 is right here. Right? This is now me integrating in the x direction. So it's our usual, right? I'm like saying we're going to integrate. Right? This is y equals x to the 3 halves. Right? And that's what that integral is giving me. Now I need the bottom half as well. So I have this 2 here. But that the line x equals 1 is actually here, the upper bound of integration. Right? So, and frankly, this is a little bit more clever, but actually this integral, right? This integral is really easy to do. Is a lot easier than the other one. Like, it's not to say that the other one was particularly tough, but this one, I think many of you can just be like, you can do very, very quickly, right? It's like, it's not too bad at all to do. So if you're kind of clever with moving things around, then you can make your life a little bit easier. On the other hand, again, if you're not comfortable with this, you don't have to do it at all. It just, it's a little bit of extra work to make your integral easier, but you don't have to do it, right? So for the first way, did we have to? No, in the sense that like what you could have done, I mean, it depends on what you mean by have to use substitution. So for example, I can integrate that function knowing that if, okay, let me put it this way. Let's say I asked you to do this. So if the integral of ln x dx is x ln x minus x, and then I asked you what is the integral of ln x minus 1, right? The answer is right? Because I know if you just change the x to an x minus a, it doesn't change anything. You just put x minus a everywhere. So you kind of do have to use substitution, but it's like, if you know that this is true, you can use that freely. I was just wondering if we did the power rule thing, like the reverse. Okay, you could try, but here's the tricky thing. So we're trying to do, what is it, 2/3? Yeah, 2/3 dy. Okay, so you could square this. Yes, it depends on what you mean, Olis, which I'm not 100% certain, and so I don't want to tell you the wrong thing. But if you're comfortable going straight to then you can. That is true. Right? It's like I've just immediately applied the reverse power rule to y minus 1. If you're comfortable doing that, then absolutely you can do that. Yeah. No, that's fine. Yeah. Right? And this is a great that I add 3 to the numerator. Right, yeah. Right? Because it's 5/3 here. Right? Yeah. Yeah, so you just want to be careful about that for sure. But this is a great thing, everyone, to kind of pick up in here, which is if the thing that you're integrating just differs by something you know how to integrate by like an x minus a term, then all you have to do is plug x minus a into your answer, right? And you don't have to do anything extra. That's equivalent to doing the substitution. And if you don't feel comfortable with that, go ahead and do the substitution. There's nothing wrong with that. But that works out. Can we do an integral with the inverse function, or is that something we can't do yet? It depends on what you mean, Chifeng. So can you expand along that? Because there are things you can do. Yeah, so do you want me to, I'm going to ask you to find the integral of an inverse function? Like that's the sort of question? Okay. Yes. Right. Yeah, so I don't want to say too much because of the assignment. But you know what? Here, if you want me let me give you the following. So do remind you got what you needed? Okay, cool. Let me give you one last question then that is strongly related to the assignment. Okay. So I want you to, for those of you who are still here, I want you to think about this and see if you can come up to it. Draw a picture. That's the best thing you can do. I will be right back. I changed the input and path. So as a hint, what I think you should do, think about the function. So I've told you the function is continuous, strictly increasing on 0, 1, and its range is also 0, 1, okay? So what I want you to do is I want you to graph, like draw the axes and draw your x interval from 0 to 1 and your y interval 0 to 1. And I want you to draw for me a strictly increasing function. Don't make it have area third, okay? Let's just worry about getting something which looks like this. Can you draw a function whose range is 0, 1 and is strictly increasing, right? And that's all I want you to do is draw such a function. And then you know that the area under the graph of that function is 1/3, and see if you can use that to solve the problem. Maybe yes, maybe no. Well, unless you don't want to give it to everyone. But yes, you were right. It's all right. Don't worry about it. No, yeah, and for sure you should be excited, right? Because you just figured it out, which is awesome. Yeah. Mm-hmm. Yeah, I think I might have brought this up at some point. Yeah. Mm-hmm. It's very closely related to the assignment questions. The assignment question is a little bit more complicated just because you're not guaranteed that it's 0A to 0B. You have to do like A, B, and C, D. And so when you draw that shape, it changes it a little bit, right? So you have to be a little bit more careful about that. I'm not even sure. Like, Jordan, are you even marking assignment 10?
I think so.
All right, let's see. TA Winter. Yes, you are.
Yeah, I am.
Yeah, okay.
To be fair, though, Olas, I'm only technically marking 1/3 of your assignment.
Also, he has absolutely no way of seeing whose assignment he's marking. So,
unless you write your name on your page, which
exactly.
some people do.
Yeah, right. So if you don't write your name on the page, then he can't see who his assignment he's marking. Because
I recognize his writing though.
Okay, well then. Actually, and so this is pretty cool. There's a reason why we specifically yeah, I don't know how. I don't know what to tell you. No, there's like 350 people.
It's students, ask for help with assignments, and sometimes they'll send me what they have so far, even if it's just the kind of thing being like, does what I've put make sense kind of thing.
Mm-hmm. Yeah, and so you get a feeling for people's writing. Does this make sense? Yeah.
It's basically always, does this make sense? Do I need to explain in more detail? That kind of thing.
Yeah. Okay, I'm going to wrap this up here pretty quick here, just because this is not like a formal question. I think some people want to see how the answer is. With the same number, the question is asking for the integration of the inverse. Chifeng, I don't quite know what you're asking, so if you can clarify that, I'm happy to answer it, but I'm not certain how to answer it as it is. Okay, let me take this up. All right, and share results. Wonderful. Majority of you did get that the answer was 2/3, and the answer is absolutely 2/3. Okay, so let's see why. Oh, well, whatever. It's not worth anything, Olas. Don't worry about it. Okay, so here's it. So this is what I was trying to say with the hint, which is to just draw a function, right? Here's 0 to 1, 0 to 1, right? And draw something which is, well, Chifeng, that didn't clarify it. So rewrite your question. We'll see if we can clarify it. So if I say draw a function which is strictly increasing and whose range is 0, 1, I don't know, I'm going to draw something like that, okay? Up to my drawing skills, this is what it looks like. And you're told that the area under this function is 1/3. Right? So the integral from 0 to 1 f of x dx is 1/3, and that's this thing. Okay? Now, when you integrate the other direction, so if you want to integrate the inverse function, you get this thing. Right? Turn your head to the right. What is the area under the curve? That's what you get. And you'll notice that the sum of these two things is just this rectangle, right? So we note that blue area plus the green area is equal to 1, right? Because that's the area of this rectangle. It's length 1, width 1. And so the green area is 1 minus the blue area. So you get 1 minus 1/3 equals 2/3. Right? Like that. Okay, does that make sense? So this is the same sort of thing that you're going to do on the assignment. The assignment, though, is a little bit different because you're not necessarily integrating from 0 to something, and that is actually going to make a difference. At the end of the day, things are still rectangles, but there might be 2 rectangles involved, for example, instead of just 1. Okay, so anyone, any last questions? Hopefully that made sense. I'm actually going to stop the recording here.